Why is the angle formed by two perpendicular lines never wrong? Because it's always right. Get it? Anyways, that's from the math book. I'll blame that one. So we're going to look today at the perpendicular transversal theorem, and we're actually going to practice some other forms of proof. Besides the two-column proof, there's also flowchart proof and paragraph proof. So first of all, let's take a look at this theorem. I've got two parallel lines, and I know that the transversal is perpendicular to one of the other ones. So here I have line S and R are parallel, and line R is perpendicular to line T. So I'm going to calculate the rest of the angles in the diagram. Well, probably the easiest thing to do first is go corresponding. So I know this angle is 90 degrees. And then I love to go vertical. That angle has to be 90 degrees. Then I'll go corresponding. That angle's 90 degrees. And then I can start doing some linear pairs. For example, these two have to be 90, and these two have to be 90. Similarly, these two have to be 90, and these two have to be 90. So what do you notice? They are all right angles, 90 degrees. So what do you notice about corresponding angles? Pretty much the same thing. They are all right angles, 90 degrees. And same side interior angles. They are all right angles, 90 degrees. Now, this is one of the only cases where you're going to have same side angles actually be congruent. Because if two angles are 90 degrees, they are also supplementary and congruent at the same time. Finally, we look at what about the alternate interior angles. They were all right angles, 90 degrees. So that means that if it's perpendicular to one of the parallel lines, then the transversal is perpendicular to the other parallel line. So this leads us to the perpendicular transversal theorem, which says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So here normally you'll be given two parallel lines. You'll have to figure out either if the two lines are parallel or if the transversal is perpendicular to one of them. So once you can establish those two things, then you can say that the transversal is perpendicular to the other line. So let's go ahead and look at this example. I've got given is that line AB is perpendicular to line BC. And I'm also telling you that angle 1 and angle 2 add up to 180. I want to prove that line BC is perpendicular to line CD. So right now we're using two-column proof. And we almost always start with a given. So AB is perpendicular to BC. That's given. The two angles adding to 180, that's also given. Now, angle 1 and angle 2 are supplementary. You can just say definition of supplementary angles. Or you could say supplementary angles add up to 180 degrees. I'll be flexible in justifications that are not traditional theorems. Okay, so now I know I'm going to use the converse of the same side interior angle theorem. So what does that mean? Okay, I know these two are supplementary and they're same side interior angles. Well, the converse is used to prove that things are parallel. So I can deduce that this line AB is parallel to CD. Aha, now that I have two parallel lines and I have that perpendicular transversal, that means it's perpendicular to the other line, CD, by the perpendicular transversal theorem. And there's your proof. So let's go ahead and look at this proof in a different form. So I'm going to do the same problem 3 times. So flowchart proof, what does that look like? Well, flowchart proof uses boxes for the statement. So what's normally in the first column will be in a box. And then it shows arrows to show how one statement can lead to another statement. In two-column proof, you can actually go out of order a little bit. And that's okay as long as you have the justification for your next step before it. So usually the steps in flowchart proof move from left to right. The justification for each statement is then written below the box. So here's an example of a flowchart proof. So you can see it's kind of like, here's step 1, and I could do the top or the bottom first. Here's step 2. I definitely need that bottom one before I can do this one. And I need This one, the angle 1 and 2, are supplementary before I can go to the next step. And then I need both of these pieces together to get to the final step. So let me fill in with what I know. This is from my given, and it's perpendicular, so that gives me an idea. It was the AB is perpendicular to BC. Angle 1 and angle 2 adding up to 180, that was also part of my given. See, the justification is under the box. Angle 1 and angle 2 are supplementary. Again, that's the definition of supplementary angles. Now remember, I had to do the converse of the same side interior angle theorem. That was showing two lines are parallel. In this case, it's AB and CD are parallel. Finally, since I know these two lines are parallel and the transversal is perpendicular to one of them, then it's automatically perpendicular to the other one. And this is a flowchart proof. Teachers are pretty cool with flowchart proofs. High school teachers, we like them. The next one, on the other hand, is actually probably more natural in the professional world, not so much in the high school world, and that is paragraph proof. So to make a paragraph proof, you start by writing what is given in sentence form. Then write down what you can conclude, the next steps, and give a reason or justification. Paragraph proofs are very flexible in structure. And this is the most common form of proof used by professional mathematicians. The reason is they have to make these giant long arguments that can be pages or even book length. So they might have entire paragraphs about one little thing. It's pretty crazy. So let's go ahead and turn this into a paragraph proof, and you'll probably see why math teachers don't like to grade these as much. So first of all, we're going to rewrite the proof. So I'm going to say angle 1 and angle 2 are supplementary, since it is given that they add up to 180 degrees. So I'll say when things are given, and you can use since, because. You could say since they add up to 180 degrees, then angle 1 and angle 2 are supplementary. You have a lot of freedom in how you write that. Next, because angle 1 and angle 2 are supplementary, and they are same side interior angles, we can conclude that AB is parallel to CD through the converse of the same side interior angle theorem. That was a lot of words, so maybe you'll notice that some of us do like that two-column flowchart proof a little better. But if you're having to make a really long argument, paragraph proof is the better choice. Okay, finally, because AB is perpendicular to BC, and AB and CD are parallel, then BC is also perpendicular to CD by the perpendicular transversal theorem. So it's kind of the same basic steps as the two-column proof and the flowchart proof. It's just a little bit more written out, and you can put in the because and the since. You can switch those around a little bit. So for further reflection, when can same-side interior angles be congruent? And hopefully you'll remember, think perpendicular transversal theorem. And how is flowchart proof similar to two-column proof? And how is it different? So I'll let you think about those yourself. And by the way, thanks to the kid who sent me a note from a different school. I love my students from other schools, and I thank you again.